All right, well, thanks for joining me for this presentation on DFS Plus water control treatment. My name is Eric Bjornstad. I'm the Technical Information Director for Bell Performance in Longwood, Florida. And today we want to talk a little bit about some issues surrounding the presence of water in fuel and storage tanks. We want to talk about the problems that water, both in fuel and water in storage tanks, can cause. We want to talk about how to detect water, so various water testing methods. We want to talk about how the DFS Plus water controller works, how it functions, and the kinds of applications or how to apply it. And then also just a brief overview of who would be the most likely people who would benefit from using something like this. So with that in mind, let's jump in and talk about the fact that water is universally present. It's universally present in the environment, and therefore it's universally present in storage tanks. Most storage tanks have some kind of air exchange, some kind of air venting, and so that air contains water vapor, and through just simple condensation and temperature changes from night and day, you get water condensing on the walls, which then builds up at the bottom of that tank. So even just through simple natural processes like this, you get a buildup of water. And that's not even to mention if you get something like if a tank is not well maintained, if it's an above ground tank and you get some rust and you get some holes that rainwater can leak in, or if it's an underground tank and you have a spill bucket or a catch bucket that fills up with water, and then you get a couple gallons of water that goes in when that tank is open up. So, no matter how we try, water is universally present in storage tanks. Now, you tend to hear water get described in three different ways, and what they're referring to is the three types of water typically seen in petroleum liquids. First one is dissolved water. Most petroleum, most fuel has some amount of dissolved water. You can't really see it because that's the nature of what dissolved water is. It's not easy to spot because it's dissolved. Emulsified water is what you have when you get cloudy fuel like this. You have micro droplets of water that are suspended or entrained in that fuel, makes it look cloudy, kind of like in these samples. And the third one is free water. Free water is what we're talking about when we talk about a layer of water in the bottom of a storage tank. Water is heavier than petroleum, it's heavier than gas or diesel, so it's going to sink down to the bottom of the tank. So water accumulates in storage tanks. So let's consider why this is a problem. Why should we be concerned about this? Well, the first reason why people in various industries are concerned about water presence is, first of all, it provides a medium for bacterial growth. Microbes, and it's not just bacteria, it's microbes, it's fungi, it's not algae, but these need water in order to grow. So you get a layer of water down at the bottom. They tend to grow at the interface, and they pull what they need from both the fuel here and the water here. They're growing here, and all they need is just a little bit of water down there to become established within a storage tank. And as they grow and as they multiply and reproduce, well, they spread to other areas of the tank and they start causing problems. So free water is the kind of water that's associated with microbial growth in storage tanks. Second reason why industry is concerned is that water, not only because of its necessity for microbial growth, but just through its sheer presence itself and the way it contributes to chemical reactions, it helps speed up the oxidation and the breakdown and the hydrolysis of fuel. Water presence is one of the primary factors in degrading the condition and the stability of stored fuel. The third reason, injector damage. It's been well known for a number of years that you get a little bit of water in the tip of a hot injector, it turns the steam, blows the injector tip out, and shuts the engine down. And then to the newer common rail engines today, which use a common rail in order to help control the injection of the fuel, with the fuel injectors. They are marvelous pieces of engineering. They have very little tolerance for water. In fact, the manufacturers of these engines specify that they want as close to zero water as possible. So there's plenty of reasons to worry about water. And since it's universally present in storage tanks, well, we need to talk a little bit about how to detect it and then what to do about it. So practices to assess and control water in tank. Well, it comes down to having good housekeeping. By good housekeeping basically means checking on the condition of the fuel, checking on the presence of water in tanks. Now, a lot of places have water sensors, and water sensors are a marvelous thing. They will detect the presence of a water phase, and they'll tell you that they'll even measure and remotely tell you the data on how much water it detects in a tank, and that's a good thing. But it's not the only thing that should be relied upon. As Ronald Reagan said, trust but verify. And so the best practice is that you rely on the water sensory data, but you also back it up with good old just human checking, and that involves checking for water with water paste. Now, if you're in the fuel industry, if you've had to manage storage tanks, you probably already know how to do this. This looks well familiar to you. Checking for water with water paste is simply you get a tank stick that reaches down to the bottom of the tank. You put water finding paste like Color Cut on it. You put it down to the bottom, and everywhere that the water touches, it will change color. You draw it back up, and you can see how deep of a water phase you have in that tank. Now, you might have, an inch. It might show you that you have an inch of water on the tank, but how much does that actually equate to? What does that mean? Well, this is where you would then take that information and you would consult the tank chart. All tanks, whether it's a convolt tank or it's a different kind of tank, they will have a tank chart. It's basically depth of the tank and how much volume that corresponds to. So if that guy had a 2,000-gallon convolt tank here, and maybe it's a single wall or a double wall, there's going to be different charts for that. But if he has an inch of water, he's going to see that means he's got 44 gallons of water in his tank. And it's important to know what that volume is, because then that will lead him to make a better decision on what to do about that water. I mean, an inch of water is plenty enough that he's going to have to take some kind of action. It's just, what is that action going to be? Well, if the water volume is sizable enough, and in this case an inch is sizable enough, what he's probably going to want to do is call somebody, whether it's a fuel polisher or a tank service company, to come and mechanically remove that water, essentially pump it out. So they would pump out the water, and then they would use a water absorbing treatment, a chemical treatment, to mop up the remaining trace amounts of water from that tank. And for cases like that, if the water volume, whether it's bumping up the trace or if it's a small amount, let's say he's only got an eighth of an inch, well then in a case like that, a chemical treatment might be better, might be more cost effective for cleaning up the small amounts of water. In these cases, Bell Performance has a solution. We have a specialty water absorbing or water controlling treatment that's called DFS Plus. DFS Plus was developed in 2007. It's a single-function water dispersing or water absorbing formula. And it functions by absorbing or dissolving water into phase with the fuel. Now, Bell Performance has other fuel treatments like Mixago, Marine Mixago, Diesel, and those traditionally have had water controllers in there, but they have used different things. They have used fluorosurfactants to essentially break the water up into small, very small, whether you want to call them bubbles, particles, whatever, very small micelles, and then suspend them in the water. Well, DFS Plus works differently because it actually dissolves the water, makes it disappear. Once that water is dissolved into the fuel, it will stay locked into the fuel. Unlike suspended water, it does not drop out due to the action of gravity over time. So with water control, what benefits will you see? Well, these benefits directly relate to the prevention of the problems that water is associated with. So you reduce the ability for microbes to grow. As an aside, that doesn't mean you kill microbes. That's a discussion for a different day, but just remember that water control is not the same as killing active microbes. So you reduce the ability or the conditions that microbes need to grow and thrive. You reduce tank corrosion. That's important because corrosion of storage tanks can be an expensive proposition. And you help reduce the likelihood for water-related fuel instability. All of these are secondary benefits because they result from the primary benefit it delivers of controlling free water buildup. But each one of these is a substantial value point for the customer for you to consider. DFS Plus has a base treat rate of 1 to 1,000 if it's mopping up trace amounts of water. If it's being used to try and control larger amounts of water, then the treat rate would vary on what the water level was in that tank. It's available in 8-ounce sizes, 1 gallon, 5 gallon, and of course 55 gallon sizes and up. What are the application recommendations? How do you apply it? Well, like with many things, especially with biocides, DFS Plus is only going to work its best if it's applied properly. And that means it has to come in contact with the water. If it doesn't come in contact with the water, it's not going to do anything. And so this speaks to the importance of making sure that it is well mixed into the fuel. So what application methods would accomplish this? Well, there are 4 main ways you can apply it. Some are okay, some are better than others. Some people have used it by they have a tank that's half full, so they have a scheduled fuel drop, so they add DFS on top of the fuel, and then they drop the fuel, and this creates a splash blending effect. That's an okay way to do it. The splash blending effect will mix it into the fuel, so that's okay. A better way to do it is to add it to the fuel and then circulate the fuel for a given amount of time. Larger tanks would need a longer circulation time than smaller tanks, but this is probably the preferred way to do it if you consider the ability of the typical customer. There's a lot of customers that have fuel circulation systems, so you add DFS, you circulate it for an hour or two, and that ensures it's well mixed in. Now, some people have gone what we should say the cheap way, or the easy way, which is they just add it on top of the fuel and they leave it to diffuse through the fuel. This is not a good way to add DFS Plus because eventually it's going to reach the water. Remember, it's on the bottom of the tank. Eventually it's going to reach the water, but it's not really going to have the kind of effect that you're expecting if you've made the decision to use it. And so, in that kind of scenario, you might think, well, it's not working. Well, it does work. It's just that it wasn't applied as recommended. And then lastly, for larger customers, some of them will use a direct injection method, whether it's they're getting a fuel drop and they inject it into the fuel line as the fuel is going in. That is an excellent way to do it. Not everyone has the ability to do that, but that would get the job done. So common questions about DFS Plus, some questions that we tend to get. These are some of the more likely questions that you might have, and ones that we have seen, a number of times. First one is a fair question: how much water will it disperse? Well, the rule of thumb is that it will disperse 2 parts water for each 1 part product. Now that is the base treat rate, the base expectation. But there are a couple of factors that will affect how close in reality the treat rate comes to this. How much circulation time? You might have a large tank and you have a certain amount of water in it, so you put the recommended amount in, but if you don't circulate it for a long enough period of time, it's not going to contact the water as well, and it may appear to be less effective. So circulation time is important. Also, the amount of fuel in the tank. Now, the amount of fuel in the tank relates to circulation because you could have 2 tanks, a big one and a small one. Both of them have, 5 gallons of water in it. So you add 2 or 3 gallons of DFS. The larger tank that has more fuel in it, you would want to circulate for a longer period of time because that DFS is going to have, it has more fuel to essentially to dilute it or to get for it to travel through in order to contact that water. So you want to scale up your circulation time for depending on how large your amount of fuel is in the tank. How does it compare to other Bell products? Well, what we said earlier was that traditional Bell products, multifunctions like diesel, like Mexico, they have had water controlling components in it, which are fluorosurfactants, non-alcoholic fluorosurfactants. And these have worked by using a micelle suspension method, essentially suspending the micro droplets of water in the fuel so that they can be carried through the injectors and into the combustion chamber and disposed of. DFS works differently. It works by absorbing or dissolving water. So you don't get the micelle suspension, but it's very, very effective at doing what it's supposed to do. This issue of dissolving versus micelle suspension relates to the next question. If you treat water and fuel with DFS Plus, and then you run it through, let's say, a fuel water separator or a coalescing filter, will the water be filtered out? There are different types of filters that are used. Some of them use, stripping mediums. The common ones are coalescing filters. And the basic answer is that water that's dissolved by DFS Plus will not be coalesced out by a coalescing filter or a fuel water separator. Water that's treated with diesel or Mexico, some of that would be because that water is accessible to that filter and the way that it works. But water treated with DFS Plus should be able to pass through a coalescing filter into the combustion chamber where it can be harmlessly disposed of as steam. Does DFS work the same in diesel and gasoline? Well, yes, it does, because diesel and gasoline are both petroleum. They're different densities. They have different auto-ignition temperatures, but they're still petroleum. And so there's no reason why DFS Plus would not work the same in both gasoline and diesel. The only thing you would want to be to keep an eye on is making sure if you're using it in regular gasoline, you want to make sure that you don't try to absorb a large volume of water in there. You can absorb some amount of water. In fact, it's been popular to do since the 1950s even. But if you absorb too much water in there, it can start to play with the auto-ignition properties of the gasoline, which is not something you really want to do. Last question, compatibility with other fuel treatments. We get this with a lot of our fuel treatments. They say, well, I've already got Stabil in my tank. Can I put DFS Plus along with it? And the answer is, well, yes, of course you can, because all fuel additives that have been registered with the EPA, which is what they're all supposed to be, they're all supposed to be registered with the EPA. For the most part, they're all made with the same kinds of things, and so they're basically all compatible with each other. You're not going to have a situation where if you take a DFS Plus and a Stabil, or you have a Startron and you add Mexico alongside of it, you're not ever really going to have a situation where one's going to cause something to happen. There's going to be a chemical reaction and your engine's going to blow up. So pretty much the answer is yes, pretty much all fuel additives are compatible and can be used with all other fuel additives. Now, who's most likely to benefit from using DFS Plus? We say what market verticals should be most interested in DFS Plus. Well, if you have an emergency backup generator, you definitely need a DFS Plus to prevent the water problems. If you're a mission-critical facility like a hospital, you definitely need DFS Plus. If you run in marine environments and water go hand in hand, definitely need DFS Plus. Anyone who stores fuel, DFS Plus would be appropriate for. And there are coordinating products that solve other problems seen in these kind of these markets have other problems. And Bell Performance has other treatments that solve those problems. Things like a Belicide, which is the biocide, Diesel Life, which is the fuel stability treatment, and tank treatment SDF, which helps control sludge and biomass. So Bell Performance has a pretty good, complete suite of fuel storage field treatments to prevent problems and provide great value for these markets. So in review, we know that water builds up in storage tanks over time, whether we like it or not. Free water layers are associated with microbial growth and with storage tank corrosion. Bell Performance has a solution for this, DFS Plus, our primary single-function water control treatment, which controls water differently than some of our other non-alcoholic surfactant packages. And it's extremely effective as long as it's properly applied according to best practices. So if you have any questions about DFS Plus or the effects of water and fuel or anything like that, you can email those questions to me here at Bell Performance. My email address, which is up on your screen, is ebjornstad@bellperformance.net. So thanks for joining me and letting me tell you a little bit more about DFS Plus. My name is Eric Bjornstad. I'm Technical Information Director here with Bell Performance in Florida. So we hope you found this useful, and we will see you next time.